Welcome to our lab nugget on working with database objects. In this lab, I'm going to challenge you to create and utilize views, stored procedures, and user-defined functions. Let's jump over to the virtual Nugget lab and get started. Here we are on our database server, SQL Nugget. So let's open up SQL Server Management Studio, and we're going to be working in the project 20 lab-working with database objects. And the first thing you want to do before you attempt this lab is run our setup.sql script to get our database into the state that we need it to be for this lab. This is going to recreate the music database, and then once that's completed, open up lab instructions, and we'll start here by working with views. So if you haven't tried these out on your own, I encourage you to do so. We're going to walk through all of the answers now, and again, you can find the solutions to these challenges in their respective SQL file. So for views, 2-views.sql, which is right here. So let's start with the first challenge here inside of views, and that's going to be to create a view named all track info that returns information from the following tables: album, artist, track, and genre, and write a query that utilizes that view. So just a very basic view here that pulls information from multiple tables. And if we open up 2-views.sql, here is my version of that view. So we do a create view, give it a name, we'll call that all track info in this case, and you can see we're just wrapping that around a query that's going to join our four tables together and pull out specific information. So let's go ahead and highlight this view, switch to MusicDB as well here, and there we go. We created the view. And again, you can see this view inside of the database underneath views. And there it is. So now to utilize it, again, we utilize it just like it's a regular table. So if we just want to see what all the data return here, we can just do a select star from all track info, and there is everything. And we can write filters on it just like it were a table. And here, if we want to grab all track info where the artist here is Pink Floyd, there it is. And we can do another one here based on genre. That's a field that's exposed to the view, so we could put filters on that as well. Let's head back to the lab instructions and take a look at our second task for this challenge, and that would be to create a view named track genre summary that returns track information by genre. Include the following in the results: genre name, total tracks, total sales, and total quantity sold, then write a query that utilizes the view. So this view is a little more complex, and it's a great example of when to use a view. This would be a perfect view that could power a summary report. So let's head back to views.sql here and take a look at what we got. So here's what it looks like. Notice that we're going to create the view called track genre summary, and we've got a query that's kind of complex here, right? Because we're joining two derived tables by using subqueries, and we're doing that because we need multiple aggregates here. We need total tracks. That's going to require a derived table. Doing this all in one query would be nearly impossible because we need aggregates from multiple tables. Then we're going to grab total sales and total quantity sold. We can get both of those in one subquery. So that's why we set up the subqueries here. And of course, you can always highlight these subqueries and run them by themselves to see what their results are. And then we can do the same with our second one here. Right there, there's the results. And now we're going to tie those all together with our outer query. That way we can pull the name out of the genre table. And then we'll just join these all on the common columns here. Notice we're joining on genre ID on both of these derived tables. So let's go ahead and highlight all of this to create the view. There we go. And now we can execute it. So we're going to grab everything from track genre summary and order by total sales descending. And there it is, a very nice query that summarizes all that information and pulls it back in one result set. Here's another query. This one is going to grab everything from track genre summary where the total tracks is greater than 100. And there it is, all 5 of them. So again, a great example of how to take something very complex, especially something that's going to aggregate data across many tables, wrap it into a view, and now anybody utilizing this view can just use it like it's a very basic table. Let's head back to our lab instructions. I've got a question for you. Name one benefit of using views. And we went over all the benefits, but just to point out some of the big ones. Number one, we can simplify our schema to our users. A lot of the time, schemas are going to be big, complex. Column names are going to be cryptic, and the only people that are going to understand them are the people that built the database, or the developers or DBAs that are in the back end, living underneath the hood all day long. So by creating views, we can alias those column names and give them sense and make it easy for everybody to work with our database. They're also great as a security mechanism. Again, we don't want to give everybody access to the underlying base tables. That should really only be for the people that live in the back end. And great as a security mechanism because we can isolate and centralize security using views there at the data access layer. All right, let's move on to stored procedures. Again, you can find the answers for our stored procedure tasks here in 3-storedprocs.sql right there. Let's start with our first one here. Our first challenge or task is going to have us create a stored procedure named getTracks that acts as a search engine for tracks with the following input parameters: artist, album, track, and genre. And then execute the stored procedure many different ways. So here we're taking a look at how to write a dynamic search engine, right? A way to get tracks many ways using many different input parameters. Let's take a look at the solution. So here is our stored procedure. Create procedure, get tracks. We have 4 input parameters that we're setting all to null, meaning these are all optional parameters. So we should be able to just execute get tracks by itself with no input parameters and get all of the data. Or we can pass in any number of parameters to get different views and slices of this data. Here's the body of our stored procedure. It's just a really big query here that pulls information from all of these tables, but the magic is right down here in our where clause. And notice I'm doing something kind of interesting here. So for each parameter that comes in, we're going to do a like, and then we're going to do an is null on the parameter. Meaning if that parameter is null, then it's going to provide the artist.name. So it's just going to link to itself, which means pull back everything for that column. If it isn't null, it's going to use the parameter and then append to it a wildcard. So this is a great way to do wildcard searches, because now we can really utilize this stored procedure to pass in anything. So we could just pass in, the first letter of an artist name or an album name or a genre name for all of these. The only thing we didn't do this on was genre, because we don't really need to do any sort of wildcards, because this is static data, right? So probably in the front end, they're going to have a list of genres to choose from. These other 3 are going to be free-form text searches. They can just type in whatever they want. The last one, they'll choose the genre out of a list, and boom, they'll get the results. So let's go ahead and highlight this big stored procedure, hit execute, and now if we head down here, look at all the different ways we can execute this. So if we just execute it by itself, this is going to give us all the data for all the columns. There it is, all 3,167 rows. We could also execute it with just the first letter of an artist. This is going to pull back any artist with L as the first letter of the name. We could also execute it with first letter of artist being L, the genre being rock. This will give us all of our artists that start with L that are in the rock genre. We could also do this by using album and track. We could use all the different combination of parameters you can think of, passing in anything for the values. And this is a really great search engine because it really covers pretty much everything you'd want to do across all of this data. And there we go. Look at all the different ways we can execute it. Cool. Let's take a look at our next one. Our next one is to create a stored procedure named add album that accepts the following input parameters: album title, artist name, and returns an output parameter for the generated album ID. And then execute the stored procedure and catch the output parameter as the return value there. So this is another interesting one because it's going to have you create a stored procedure for adding data into the database, capturing the generated ID, and then passing back to the user. So this will be a good one for developers to use in their front ends because they can create data, get that ID back, and then tie that back to the front end in their results. So they wouldn't need to execute another query after the stored procedure to get that record into the result set. Let's take a look at the solution for this one. So here it is, add album. So there is our parameters. We have 2 input parameters, album title, artist name, and 1 output parameter, so we can send that album ID back so they can capture that inside of a variable. Here is the body. So the first thing we need to do, because we're allowing them to pass in the name of the artist, is we're going to need to get the artist ID associated with that name. Because remember, inserting into the album is going to require an artist ID, not a name. So we do a little lookup here. First, we declare a local variable called artist ID, and then we do a select into that variable, grab the artist ID from the artist where the name is the artist name. Then we're going to insert into album the title that they pass in here, as well as the artist ID that we did the lookup for, and the values are going to be the input parameter there, as well as our local parameter for artist ID. Then we're going to store in the output parameter the result of add identity, which will return us the latest auto number that went in to this table. So let's go ahead and highlight all of this to create the stored procedure. All right. And now we can utilize it. So again, to capture that output, we first need to declare a variable. Whoever's executing this stored procedure will need to declare a variable. Then when they execute our stored procedure, they're going to need to fill in that output variable or that output parameter with that local variable that they declared, and that will fill up that variable that we can use outside of the stored procedure. So let's highlight all this. This is going to add an album here called new album for the Doors, and we should get their new ID printed into the messages of the results. Let's do it. There it is, and look at that. There is the ID for that newly generated album. Back to our lab instructions. I've got a couple of questions for you here. Name one benefit of using stored procedures. A couple of them again. We can isolate code on the server side and reuse it many times. Remember, stored procedures are like little executable SQL programs sitting on the server. One of the benefits. Another one is, again, a data access layer and a security mechanism, because we can flow access for anybody that's utilizing these stored procedures through that layer. Another question here, what is the difference between input parameters, output parameters, and return values. Remember, an input parameter is data coming in that we utilize within the stored procedure. An output parameter allows us to send data back outside of the stored procedure, so anybody executing it can retrieve that data. And a return value is generally just going to be a code that describes the status or the state that something may have happened or something that you want to relay back through the return value. Let's move on to our last challenge here, which has to do with functions. So again, you can find the solutions here in for-functions.sql, right down here. And the first task is going to have you write a query that uses system string functions to reverse uppercase, lowercase, and count the length of all track names. So just a very simple query here that'll have you utilize some of the common string functions. So if we head back to Solution Explorer here, take a look at our solution. Here's a very simple query, right? Select the name, then reverse the name, then upper the name, then lower the name from track, and there's all the different variations of that. Now our next task is an interesting one. I'm going to have you create a scalar user-defined function named album length that accepts album ID as an input parameter and returns the combined length of all the tracks for that album. And you'll want to use the milliseconds to seconds UDF to make it human readable in the form of hours, minutes, and seconds. And I included that in setup, so that should be inside of our music DB here. In fact, you can verify that by expanding programmability, expanding functions, expanding scalar valued functions, and there it is. Remember, you can call other functions from within your functions, which is exactly what we're going to be doing here. So let's head over to the solution here. And here is that function. So it's called album length. We're accepting album ID as an input parameter, and this is going to return our scalar value, right? A scalar function returns a single value, and it's going to be a character field that's 12 in length. So here we set up the body of the function. We're going to declare a local variable. Then we're going to select into that variable a sum of milliseconds from track. So this is just going to grab the total milliseconds, and then we're going to return total album length by passing that variable into our user-defined function that we created in our previous nugget, milliseconds to seconds. So let's go ahead and highlight all of this and hit execute. All right, so that's going to create the function, and now we can utilize it. Let's first utilize it by just selecting from album length and passing in 100. And this should just give us the time for that album. There you go. That album is 40 minutes, 46 seconds, 0.937 milliseconds. And now we could utilize it another way by tying it into a query. And this is going to give us the album length for all of the albums. Let's hit execute. Look at that. There's the album length for all of the albums inside of our album table. Pretty cool, right? And here's another one that just shows that we can even put filters on top of the results. We're going to use it in the where clause. We're going to say, give us everything that's greater than 2 hours in length. And there it is. So that was a fun one. Let's head back to the lab instructions here and take a look at our last one, which is going to have you create an inline table-valued function named album tracks that accepts album ID as an input parameter and returns tracks for the supplied album. So here, again, just getting you familiar with how to create a table-valued function. If we look at the solution here, a very simple function. Now, we're not creating a multi-valued table-valued function. Again, that's where we define the actual table and then fill it up with data and return it. This is a very simple inline because all we're doing is saying returns table, and again, it's going to infer the results. So all of the columns are going to make up that table. It's going to use the names and the data types from them. And then it's inline because we're just returning the results of a query, right? We're not using multiple statements inside of our body, so we do not need a begin and an end. And so we're going to create it, accept album ID. It's going to return a table as, and then our return here is just going to be the result of this query. Again, this is a great way to set up parameterized views. So we can select from a view, put parameters on top of it, and now we've got ourselves a parameterized view. So let's go ahead and create this. And now we can utilize this function just like a table, right? We can say, hey, give us everything from album tracks, in this case for album 100. Here's another way to utilize it. We can join to this, right? And here we're going to use the cross-apply operator. And this is what's going to allow us to do a join to a user-defined function that accepts parameters. So here we go. Hit execute. And there it is. So we join those tables together, and notice that we're passing the album ID of our outer table as the parameter to our user-defined function. Let's head back to our lab instructions and finish this nugget off with a couple of questions around functions. Number one, name one benefit of using UDFs. Now again, a lot of the benefits are going to be the same as stored procedures. We can store code on the server, reuse it many times, cut down on network traffic. But one big one that separates it from stored procedures is we can use user-defined functions in our queries, in our selects, in our froms, in our joins, and we cannot do that with stored procedures, right? We can just execute them. So again, what's going to help you decide what to use, stored procedure or function, is really the restrictions around both of them. Question number 2, what is the difference between scalar and table-valued user-defined functions? Remember, a scalar UDF just returns a single value, where a table-valued UDF is going to return an entire table that we can utilize just like a table or a view. So that's our lab for working with all the major database objects here in SQL Server and most database platforms: views, stored procedures, and user-defined functions. I hope this has been informative for you, and I'd like to thank you for viewing.